Hey everyone, welcome back to the channel. Today we are going to simplify a concept that often confuses beginner in machine learning: accuracy, precision, recall, and the infamous type 1 and type 2 errors. Do not worry, by the end of this video, you will not only understand them but be able to explain them like a pro using a simple examples. We can take spam reduction in emails. So imagine you are building an email filter that automatically classifies email into either spam or not spam. The goal is to keep your inbox clean and make sure you don't miss important messages. For example, win a free iPhone, suddenly an spam. Meeting at 3 p.m. Actually, it's not an spam. Limited offer inside, it's spam. Invoice per services, not spam. So the model predicted this meeting at 3 p.m. Is spam, which is incorrect. What it was not an spam, so it was correctly predicted. Then limited offer insights, again we predicted as a not spam, but it's actually a spam, so it's in classified incorrectly. So in terms of confusion matrix, we have this column of actual classes where we have two classes, spam, not spam, and the predicted are the spam, not spam. We put into the row header. Now in those cell values, we can have different type of options. For example, here it is true positive, because the message was actually a spam and be predicted as also as a spam. So we classify as a true positive, which is the correct one. Let's see the diagonal again. So diagonal here is true negative again. The true negative is just a actually it's not a spam, and you all like your model is classified correctly as a not spam, so it's a correct one. From the negative side, that is not spam class side, it's true. This second character tells us about what class it is. Negative class. Negative here is not spam, and you are saying that is these are true itself. Why true? Because you also you predicted as a not spam as well, which is a negative class, so that's why it is a true negative, and it is a true positive. Same for this as well. Positive refers to the spam, and these are true spam itself. Okay, because you are your ground truth and the actual sample, it was saying that it is a spam, and you predicted as a spam as well. Now here here the important part comes where you actually your sample actually are not a spam, but you predicted as a spam, which are the false positive. Most of the cases you will find this thing, false positive. You predicted something as a positive class, but actually it was not a positive class. In this case, it was not a spam. You predicted as a spam. The P part, the false part tells us this is a false spam. Actually, it was not a spam because the actual value is, you can see, it's a not a spam. Same for this false negative. Here you predicted as not a spam, but actually it is a false one. So it was a spam, but you predicted as a not a spam. Okay, I guess this much is clear. Let's see some real example. Let's suppose we have some samples of the data. Here I'm took total 8 samples. Sample size is 8. So these are the ground truth sample classes, and these are the predicted by the model itself. So let's calculate each of the matrices by hand itself. So accuracy is very simple. accuracy, what it says, the numerator says how many of samples correctly predicted. Okay, so let's see how many of them are correctly predicted here. This is correct. This is not spam, but actually it was spam, so not correct. Correct, 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 correct. Total 5 examples we can see it was correct. And how many total examples are there? That is denominator. How many of total samples? The total samples are very simple. 8 total samples are there. So the answer would be 5 divided by 8. Very simple, the accuracy measurement. Okay, let's go to the other matrices, that is precision and recall. So in the precision, we have two classes. One is spam, other is not spam. So precision will be different for both of them. For the spam it will be different, for the not spam it will be different. What exactly precision tells us? So it tells us that how many of correct spam predicted by the classifier. So always take care, once you calculate the precision for any class, look up for how many of that class predicted by the model. For example, here spam is predicted by how many times by model. Okay, let's erase these tick marks. Again, so how many of spam is predicted by the model? 1, 2, 3, 4. Sorry, it's 1, 2, 3, 4, 5, right? Total predictions are done here is 5. And how many of correct spam predicted by the classifier? In out of 5, I guess total corrects are, this one is correct, this one is correct, this one is correct. So there are total 3 correct predictions happened here. That value will be 3. So again it is 3 divided by 5 is the our answer. What about recall? Recall is just in the denominator part, will take the ground truth instead of the predicted values. Here we have the, for the spam we have the ground truth. The actual spam were 1, 2, 3, 4. There are total 4 ground truths of spam present. Total samples of spam were 4. And how many of correct spam predicted by the classifier? Again 3. That number would be the same what we had earlier, because in out of 4, 1, this one, this one, this one is the correct one, because the model is predicted correctly spam and actually it was spam. So these are this number is 3, this is 4, and this is 3 by 4. This is the recall of spam, this is the precision of spam. Now this is a broader level we have seen that in terms of calculation, but if you want to go by formula, then you can also go by the formula as well. We saw earlier that this matrix confusion matrix. Here we have these particular values: true, positive, true, negative, false, positive, false, negative. We can denote in terms of data as well. Like this is the positive class, which is a spam class. How many of them predicted as a true and actually a true? So the numerator is true positive divided by true positive plus false positive. It is simply true positive divided by true positive plus false negative. So here true positive is how many of them actually spam and predicted by the model as a spam as well. So those numbers are 3. What is true positive here? 3. What is false positive? False positive means our model has predicted as spam. This last character tells us, but it was not a correct spam because the actual value of that sample was different, which was not a spam. So let us look for this. Spam is these are the spam. Let's erase this first. Okay, so positives are by our model predicted positives are spams are this one, this one, this one, this one, this one. How many of them false? This is false. This is false. That number is 2. This is matchup. 3 divided by 3 plus 2, which is 5. 3 divided by 5 is our answer. Here is true positive, which is again 3. True positive plus false negative. Let's look for the negative. So negative is the not spam, right? So how many of them not spam? This is not spam. This is also not spam, right? But this is not spam, but how many of them are false? So this is false again. This is not false. This is not false. So this is only 1. 3 divided by 4. So you can use either this way, like calculating the total values and create the answer. Either you can use this formula using our confusion matrix. Both way you can solve. But I would recommend that by solving manually, you always do calculate like numerator denominator in terms of numbers, and then you get the answer. But if you go with this way, it is good for calculating by our logic or code. Then the confusion matrix is a way to solve it. Now last thing comes, which is the type of error. This is very important. Type 1 error, type 2 error. So if you miss an important emails, that is you classify as a positive. I mean it's a spam, but actually it was not a spam. That is type 1 error, which is this part. So this part calls type 1 error. Okay. So this false positive called type 1 error. And the mail was actually not a spam. Mail was not a spam, and you classify it as false, which are the type 2 error. Okay, let me explain this one more time. So basically you're saying that negative parts tells us it's not a spam. Okay, but it was false. Means your mail was your model is predicted as a not a spam, but it was false. Means it was a spam. But your model is saying it's a not a spam, which is a type 2 error. Okay, so this called type 2 error. In the medical industry, it is very important having the type 1 error, calculating type 1 error and type 2 error. For example, if you see, if any people is having some severe issues, some sickness, and we have some test report, and in the test report it says type 1 error, means test says you are sick but you are actually healthy. So you panic, go through unnecessary treatment, spend money, stress, all those things will come up, right? In case of type 1 error. But type 2 error is very deadly. Here, what you are saying, test if you are healthy, but you are actually sick. For example, in case of cancer, you have someone has cancer, but our model has predicted you don't have cancer. So he will not go for the treatment itself, right? That is our type 2 error, which is very deadly in case of such scenarios. Other scenarios in airport as well, we see in the cancer screening, we saw that we prefer higher recall because the higher recall covers this false negative part. In airport security, type 1 is okay with false alarm, like actually you don't have anything and the alarm is like it is having false alarm. But type 2 error, missing a threat. For example, someone has bomb and it was not able to detect by the airport security. So that is type 2 error, which is very risky. I hope you understood the familiar with this concept of precision recall, type 1 error, type 2 error. Thanks for watching the video.